Morning, everyone. Glad to see 500 of my closest friends here to join us for a little talk this morning. I'm Tim Zahrn. I'm a specialty products area manager with Asphalt Materials, and I work with our J-Band product, which are in our J-Band booth. But today I'm going to talk mainly about rumble strips and safety features that we have on our roadways, and then funding that we can use to get those safety features put in place. So, quick little down and dirty about what J-Band is. You'll see it referred to a lot of times as VRAM, or void reducing asphalt membrane. That's the specification that we'll typically see an agency use to specify the process and the product. J-Band is our product name for that VRAM material. So what J-Band is a polymer modified asphalt. It's highly polymer modified. It's sprayed 18 inches wide before we pave the surface course. And it's going to go down in that intended area where that longitudinal joint is going to go. 9 inches either side of that joint, studies have found, have the highest voids of the rest of our pavement. That lets water and air get down in there, and that starts to blow that pavement apart there right at the joint. Typically, that's the first part of our pavement that we see fail. I've got a sample of the material if you haven't had a chance to see it yet. It is polymer modified. The thickness of that material is how thick it goes down when we apply it, kind of coarse graded overlay, 18 inches wide. It goes down at about a gallon per square yard. Sprayed at about 300 degrees Fahrenheit, 10 to 15 minutes, it cools, and then allows construction traffic trucks to pull over the top of it, back into the pavers, start paving over the top of it. So it can be sprayed right before paving, or it can be sprayed a day or two before paving. It's just going to lay there on the surface. The way it's designed, though, is it doesn't stick to tires. That's the plan. So that's why you can spray a hot asphalt underneath.
Sorry, I missed it. How long did you say it takes to set up?
10 to 15 minutes. Spec calls for 30 minutes. It has to cool enough to get across it at 30 minutes. Once the surface hits about 130 or so, then you can pull trucks across.
So it's something when you say rubber won't
pull it up. Yeah, you can either tap on the tires.
Really?
As long as they're crossing it. Now, if they're
right.
They're going right down it. But if they're pulling across it like you see there, it doesn't. Then when we pave over it, the heat of the asphalt and the compaction causes it to go up into the surface. So that's what the idea is. So we're filling those high void areas with the polymer modified asphalt. So that's, we can talk a lot about J-Band in here. We have a lot of people here to talk about that. I just want to give you a quick little brief idea of what it is. So let's hop in to do a little quiz. Have several percentages listed on the bottom here. What percent of fatal crashes do you believe are the result of lane or roadway departures? Somebody pick a number, shout out a number in that bottom one. What do you think?
55%.
55, all right. We got a winner up front here. You got it right. So then, of those, what percentage of opposing direction crashes occur on undivided two-lane highways? So that's probably going to be a pretty high number, right? So yeah, if we're going across the center line, we're going to be in that 75% range. And of those crashes that involve overtaking, what percentage of those crashes that involve overtaking or passing maneuvers? So not because we just drift across the center line, but because we are crossing over and trying to pass. It's a pretty low number. So that tells us it's really about that distracted driving or the reasons we're crossing that center line. What percentage of drivers actually admit to the fact that they dozed off during driving? People don't want to admit that, right? Yeah, so yeah, we're doing that. So, and obviously leaves the bottom answer is centerline rumble strips can reduce head-on crashes by as much as 65%. So just using a centerline rumble strip is a good safety measure that we put on our roadways. In Ohio, in 2019, there was almost 7,400 centerline crashes left the centerline in Ohio in 2019. And on those crashes, there were 160 fatalities. That really caused Ohio to dive into trying to put more rumble strips on their roadways. We're not seeing it just in Ohio. It's happening nationwide. And you see how many roadway departure crashes we had nationally. There are over 16,000 fatalities, I should say, because of vehicles leaving the roadways. Studies have found that using centerline rumble strips can reduce those crashes or those fatalities by up to 50%. So just by doing a rumble strip, a simple safety feature, we can really reduce our crashes on our highways. So states like Wisconsin in the past 4 years have seen a growth in the use of centerline rumble strips. And these are lane miles that Wisconsin specifically put out there for centerline rumble strips. So we've seen a lot of rumble strips being put on our roadways, but I talked about that high void area in the map that the VRAM J-band product can take care of. So what does the effect of that rumble strip really have on those voids in that high void area of our pavement? We've had a lot of studies looking at rumble strips and how they can affect the service line of a centerline joint. And we see a picture like this. A lot of times we'll see that potholing where the rumble strip's at, and the rest of the pavement's in pretty good shape. A lot of the studies have been subjective, but there was a study that was actually done this last year by DiCarlo in 2023, and it was presented at TRB. And I have the poster over here, and you can take a look at it after we're done. And this is it up on the screen. But really, what we're looking at is grinding into that rumble strip. How does it affect that surface? Does it add cracking to that surface? And then how does that affect the permeability of that joint? So we're taking the high void area, we ground in a rumble strip. We're putting a funnel right there in that high void area. That's what our concept was. But then how can we try to mitigate that by using a VRAM product underneath it? And this study is taking a look at that. So really looked at the permeability. There's 2 different locations we looked at. They actually built this rumble strip specifically to take a look at this for the study. And we took cores all the way throughout the rumble strip, both with VRAM, without VRAM. We also did just a control joint with no rumble strips in it and took a look at the permeability of those joints. And that graph there shows if you have a ground-in rumble strip, high permeability in that joint. Water is just going straight through. And there's a display over here that can show where we have VRAM in it and where we don't have VRAM, how fast that water can go through that asphalt. So we look at the permeability, and using a VRAM underneath a rumble strip takes the permeability basically down to 0. We're cutting off that water, keeping it from getting down in underneath that pavement. If it gets underneath the surface, it's going to cause delamination, and then that rumble strip material is going to start popping off. There's another study, the National Road Research Alliance is a group of 14 state DOTs and over 80 private and other agencies, academia, taking a look at the effect of using a VRAM type material underneath rumble strips. And it's across several states. You can see the states there. This research report is just starting, but they do see that using a VRAM does reduce permeability. That's all the studies and the concepts. What's it look like in real life? This is one of the first J-band VRAM projects that we did in 2016 in Indiana. It happened to have control and test sections of VRAM and rumble strips. This project is 8 years old. This picture was taken just last month, and we can already see on the non-VRAM section where the crack's getting pretty wide. We're starting to see actually water getting underneath and doing some delamination adjacent to the adjacent to the joint where the VRAM wasn't used. Where it was, you see this. It's really hard to even find the joint. So that pavement's 8 years old, and that's the type of performance we're seeing in just 8 years. Here's one in Ohio, not quite as old, only 6 years old, but once again, no VRAM. And we see all that cracking starting to happen where that rumble strip is at. Whereas where the VRAM is, we might see a little bit of an opening, but there's no adjacent cracking like we're seeing there. So this is proving what we're seeing in our studies and what our thought process was as far as trying to keep water out of that joint area, and that rumble strips do tend to get in there quickly. Margus and
No, that's
we also take a look at sustainability of using VRAM, and that's a very important aspect in our industry today. Listen, there are 3 pillars of sustainability: a social, environmental, and economic. We have studies on all of these. I'm going to dive into a couple of them here in this one. And the main idea is we're trying to do the things the right way around all these goals. Let's take a look at the economic sustainability. So this is a study done by the Illinois DOT, where they took a look at using a VRAM product underneath their longitudinal joints and how it affected the life of that pavement. Obviously, there's going to be a cost at the beginning of the project, but if you install a VRAM. But they wanted to see what it would look like if they delay their overlay between 1 and 5 years. So year 0 on this graph is year 15. They expect to get 15 years out of their overlay life. If they delay their overlay by 1 year, the value to them is $6.46 per foot. So just by delaying that overlay 1 year, and they also do a route and seal. They plan a route and seal at year 5 and year 10. So if they use a VRAM product, they don't have to do those route and seals. So they got rid of those when they did this economic calculation. If they delay it 2 years, it's $6.79 per foot. That $2.39 that just popped in there, that's the average unit price per linear foot of an installed VRAM in Illinois in 2019. If they delay it 3 years, they get a $7.58 return on their investment by delaying that overlay by 3 years. So instead of year 15, do it at year 18. That's about 3 times the initial cost of that actual product. They expect to get 3 to 5 years, and if they get 5 years, it's worth about $10 a foot. So it's by taking a look at that, they've saved 5 times that initial cost. You say that Illinois did publish this report, and they expect to get VRAM to provide a life extension of 3 to 5 years on their overlays, just because they don't have to go out there at that center line. And then the benefit of that is 3 to 5 times the initial cost. Now, this was presented at the TRB in 2021. If you want to take a look at that page. The other pillar I want to look at is the social, sustainable pillar, and we're going to take a look at what that means. And we really look at this as part of safety. The study showed that there are far fewer estimated injuries if you use a J-band VRAM product as compared to typical construction. Number one is when you use a VRAM product during construction, you don't have to take densities at that center line, whether it be cores or gauge testing. You don't have to be out there on that center line where traffic is coming by. You also don't have to send our maintenance crews out to do this, to do pothole patching at that center line with very little traffic control and having live traffic next to us. So it really does reduce safety if we don't have to be out there at that center line joint. And using J-band, you're going to get better safety measures. The other aspect of that is the rumble strips. Using rumble strips does increase safety, but we need to be able to protect those so we don't have to pothole patch them like this. So in summary about VRAM underneath rumble strips and the safety aspect, we're seeing them being used more and more. It's placed in that weakest area of the pavement. If we use a VRAM underneath that centerline rumble strip, we're to keep water from getting down in there, and then we can surface seal that also with an RPE product.
Thank you.
So we looked at those 3 pillars. There's an economic pillars, that life cycle cost savings. We do see reduction in energy use. That didn't go into the environmental pillar, but we have a whole study on that. And then our social pillar is we have reduced crashes and reduced maintenance crews being out there at that center line. That's all good. Now, how can we help pay for these safety features, right? So rumble strips and widening of roadways are approved use of highway safety improvement funds. These are funds from the federal government that come to the state, typically distributed to local agencies. They could pay up to 90% of those safety features that are added to that roadway. In Jersey County, Illinois, they did a safety project using HSIP funding. They widened their old 22-foot roadway out to 24 feet, and they added 4-foot safety shoulders. They put rumble strips at both edges and at the center line. And then they put in a LJS VRAM product underneath those rumble strips. What was unique about this particular project is they pulled those 12-foot blades and those 4-foot shoulders, the surface force together. So there's no joint out here, which is where we would typically put a VRAM product. But they put the VRAM underneath that rumble strip just because they want to keep water from getting down into that pavement. So we have a video here that we can play.
We are currently performing application on County Highway 9 in Jersey County, better known as Otterville Road.
We had an existing pavement that was approximately 25 years old, and we'd been having several fatalities on this road and also roadway departure accidents. It was time to make improvements to it. Over all the alternatives we had on this job, we decided resurfacing was the best because we could widen that road, but also utilize the J-band on the project.
The Otterville Road project that Jersey County is doing is a great safety project. They've added shoulder width to their pavement. And they're putting rumble strips at the center line and not on the edges. So creating a much safer roadway for the folks that use their roads. By using a VRAM product underneath those rumble strips, those safety features are going to last throughout the life of this pavement and make it a safe road.
The rumble strips in themselves are a safety enhancement. It keeps the public awake and aware and on the road. However, when they are grouped into the pavement, it provides some open spaces for water to settle. And over time, that water can break down the pavement surface below and deteriorate the pavement.
Well, then it's a place for water to migrate down into there. And then you have to worry about a maintenance problem there with that water infiltrating down in there.
Paving joints are the first area to fail on a project. As you drive down a highway or any road, you'll notice that the longitudinal joint cracks, or you'll see cracks in your lane. It was found that where J-band was placed underneath the pavement, there was very minimal cracking, where the rest of the pavement had already fallen apart. Once we started full-bore commercialization with projects in the state of Illinois, over time we've watched those projects. They've seen 7 and 6 winners respectively. And there is just a hairline crack at the top of the surface. And that crack is maybe at the most a 1/4 inch deep on these projects. It has a tendency to migrate both horizontally and vertically into the mix. And with this highly polymer modified material, by placing it underneath the intended area of the paving joint, you're actually making it impermeable to water. It performs.
So by applying the VRAM, that secures that pavement and keeps it intact.
It's economically beneficial to the residents of the county because now they have a smoother road, a longer lasting road, but also one that's maintenance free, so we're not out here with our crews shutting down traffic to take care of the maintenance operation.
One other thing that the county did on this project was they utilized Highway Safety Improvement Program funds to do the project. It's difficult for some counties to be able to get resurfacing projects done, and that type of a program that the state of Illinois gets from the federal government to pass on to local agencies is very important.
The Highway Safety Improvement Program is a federally funded program available to local agencies to help reduce the crashes that are occurring on their roadways. So it's important to be aware of the HSIP opportunities that each project can present.
We were able to take those dollars and stretch them farther with that money and make further improvements.
For the initial cost of the product, by the time you get into your second sealing cycle even, you've more than saved that initial cost. And that cost that you save can be put into other highway projects.
Collaborating with Asphalt Materials is great because we're coming together to provide solutions that are cost effective and provide longevity and safety all in one.
So that was a unique project, like I said, where they did use Highway Safety Improvement Program funds to do the project, but also be able to put the VRAM underneath there. All local agencies, all states have some type of a program with HSIP. It's a federal program. There are specific dollars that are set aside. So if you're working with any agencies that you know that might want to do a safety project, it's a great tool and resource to collaborate with them on. Well, this is just a quick summary. Rumble strips are obviously a very good safety feature that we can add to our roadways. By using a VRAM underneath there, we're going to get longer term performance out of that rumble strip. You're going to get improved life cycle cost savings, and you're also going to eliminate the need for maintenance at that longitudinal joint. So obviously there is HSIP funding available that we can help pay for these projects. We have a lot of information on our website, thejointsolution.com. A lot of these resources that I described are there, plus a lot of other information that we have around the booth here. So I just want to thank you guys for sticking through me for 15-20 minutes here through my presentation. I appreciate that.